Hello friends, this video on organic chemistry basic part 4 is brought to you by examfear.com. No more fear from exam. There are tons and tons of organic compounds. So there has to be some ways to represent these organic compounds so that the chemist can understand which compound you're talking about, right? So there are 4 ways of representing organic compound. The first is the complete structural formula where you actually end up writing the whole structure. For example, ethane, if you see the ethane, it looks like this. 2 carbon bonds and each of these carbon are attached to 3 hydrogens each. This is how ethane looks like originally in the lab if you see from a magnifying instrument. So there is a condensed structural formula. So for example, you have a big compound, right? It's very difficult to remember the structure and very difficult to write the structure also. So instead of writing the whole structure, it's a little condensed where you remove all the single bonds and you just condense this. Example, you remove all the single bonds, you get this ethane. This is the second way of representing the organic compound. The third is the bond line structural formula where you represent in this fashion where each dot represents a carbon and corresponding hydrogen atoms to make sure that each of these carbon atoms has 4 bonds linked to it. And the fourth way of representation is 3-dimensional representation where you actually show how it looks. Because if you see for example methane in the lab using some magnifying instrument, you will see it's a 3-dimensional structure where one hydrogen is coming out of the plane, the other is going inside the plane, and the 2 hydrogen are in the plane. So that is the structure actually, the 3-dimensional structure. So to represent that, we use 3-dimensional representation. So let's study all these things in detail. The first is the complete structural formula. As I told, so ethane, if you see, the structure formula exactly tells you how it looks. There are 2 carbon by a single bond, and each of these carbon has 3 hydrogen attached to a single bond. If you see ethene, 2 carbons are joined by double bond and 2 hydrogens each attached to these carbon are by a single bond. Similarly, ethine, if you see these 2 carbon are joined by triple bond and each of this carbon has a hydrogen attached with a single bond. Similarly, methanol looks like this. So complete structural formula gives you an idea of how the structure is, right? But as I told, if the structure is too big, it's very difficult. For example, I have something like this, right? So it's very difficult to represent this with all with the carbons now. It's very difficult to represent this in the structure. So we use condensed formula. What we do for condensed formula, what we do is we just remove all the single bond. For example, ethane, the structure was something like this. We just drew. Remove all the single bonds. What you get? CH3. And then you remove the single bond, CH3. This is what you get. Let's try for ethene. Ethene we have seen it was CH double bond CH like this. Remove all the single bonds, so this becomes H2C, and then there's a double bond, you can't remove double bond, CH2. Similarly for ethyne also you can do, right? So a condensed formula is nothing but from the same structure formula you get it, just you have to remove all the single bonds. And then we have bond line structural formula. So here what we do, if the chemists are a little lazy to write CH3 and all, what they do is they use bond line structural formula. So each of these represents a carbon. So how to get this? For example, I have the structural formula. This is my structural formula. This is my condensed formula actually. This is my condensed, and this is my structural formula. So what you do is you remove all the hydrogens and you replace carbon with a dot, you will get this structure. For example, in this case, you see if you remove all the hydrogens and replace carbon with a dot, you will get this structure. This is also one carbon. Here also if you see this is my condensed formula and this is my structural formula. In this case, remove all hydrogens and replace carbon with dots. There are 1, 2, 3, 4 dots. There are 1, 2, 3, 4 dots. In second carbon you have bromine attached, so it has a bromine. You get this structure. So it's very easy. You remove all the carbon with dots. Remove all hydrogens, replace all the carbon with dots, and then you get this condensed form. We'll take more examples. Then cyclopropane. If this is cyclopropane, you remove. You want to get this formula, condensed double line structure, bond line structure formula. Remove all the hydrogens. Replace carbon with dots. We'll get 3 dots. You join this with single bonds. You get cyclopropane. Also from cyclopropane, I can get this formula also. How I'll show you. See, cyclopropane. From cyclopropane, I want to draw this formula. What you do is, all these dots put 3 carbon. Correct? They are single bond, join them by single bond. Now each of the carbons should have 4 bonds. Please note, each of the carbons should have 4 bonds, because one bond is 2 electrons, the carbon should have 8 electrons in the valence shell to be stable. Correct? Each of the carbons should have 4 bonds. Why 4 bonds? Each bond is 2 electrons, 4 bond is 8 electron. So each carbon should have 8 electrons in the valence shell to be stable. So it has 2 bonds. 2 more bonds is required, so just create 2 more bonds and add hydrogen. Here also 2 bonds, add 2 more bonds, add hydrogen. Here also 2 bonds, add 2 more bonds, add hydrogen. So if you see, from here we could easily get this. Similarly, cyclohexane, from the structural formula, if you want to find the bond line structural formula, remove all the hydrogens, right? And all the carbon put as dot, and then there's a chlorine here, add the chlorine, you get this. From this, I can get this easily also. I can just try to show you. 1, 2, 3, 4, 5, 6 dots. So I'll put 6 carbons here. 1, 2, 3, 4, 5, 6 carbon. All these carbons are joined by a single bond. So let me join them with a single bond. And this carbon has a chlorine. Add this chlorine. Now see, this carbon has 2 bonds. 2 more bond is required. So add 2 more bond and add hydrogen. This carbon has 2 more bond. Total 4 bonds are required. So 2 more bonds are required here. So add 2 more bonds. This carbon also has 2 more bonds, 2 bonds, 2 more bonds are required, add these. This carbon also has 2 bonds, add 2 more bonds. This carbon has 2 bonds, again add 2 more bonds. This carbon has now 3 bonds, so only 1 bond is required and add hydrogen. And this is the structure. Similarly, cyclopentane also, if you see, just to get from the structure formula to the bond line structure formula, just remove all the hydrogens, assume carbon as dot, and you get this. From here to here is very easy. Now let's understand the 3-dimensional representation. So as I told, actually if you see any organic compound in the lab with some magnifying instrument, you'll see it's a 3-dimensional structure, right? So this is how a methane looks. If you see these 2 hydrogens are in the plane, this hydrogen is coming out of the plane and this hydrogen is going inside the plane, and this is my carbon. This is how methane looks. To show this in 3-dimensional way, if let's suppose chemists want to understand the structure also, in that case we have the 3-dimensional tray. So we have, for this we are using something called wedge. So this is a solid wedge, this is a solid wedge, and this means that the hydrogen is coming out of the plane towards the observer. Let's suppose we have observer here. So this means that this hydrogen is coming out of the plane. This is the dashed wedge. This is a dashed wedge. So this means that hydrogen is going inside the plane, away from the observer. And these are straight lines, which means that these hydrogen are on the plane. So if you see, these 2 hydrogens are on the plane. So assuming I have put one paper sheet here and these are on my plane, this hydrogen is going out of the plane. This hydrogen is coming from the plane. Correct? This hydrogen is going into the plane and this guy is coming out of the plane. So this is how you represent using wedge. This is solid wedge, which means that the hydrogen is coming out of the plane. This is a dashed wedge, which means hydrogen is going inside the plane. Let's take some numerical on this. So expand each of this following condensed formula into the complete structural formula. So we'll do the first one. Let's count the number of carbon. 1, 2, 3, 4, 5 carbon. So let's draw 5 carbon. 5 carbon, and let's number them 1, 2, 3, 4, 5. Let's number them 1, 2, 3, 4. The first carbon has 3 hydrogen, so add 3 hydrogen here. The second carbon has 2 hydrogen, so add 2 hydrogen here. The third carbon has 1 oxygen, and oxygen is always a double bond. OH is a single bond. This is something you should remember. So we'll add 1 oxygen with a double bond here. Double bond. Fourth carbon has 2 hydrogen, and fifth has 3 hydrogen. So this is how this will look like. Easy. Let's take this 1, 2, 3, 4, 5, 6, 7. There are 3 carbons here and 8. There are 8 carbons, right? 1, 2, 3, 4, 5, 6, 7. Sorry, 7 carbon here. Right? So let's draw 7 carbon first. 1, 2, 4, 5, 6, 7. First carbon has 3 hydrogen. 1, 2, 3. Second carbon has 1 hydrogen and 1 double bond. The third carbon has 1 hydrogen, right? Fourth, fifth and sixth has 2 hydrogen, and the seventh has 3 hydrogen. This is the structure. Just confirm each of the carbons should have 4 bonds. First carbon has 1, 2, 3, 4 bonds. Second has 1, 2, 3, 4 bond. Third has 1, 2, 3, 4 bond. This guy has 1, 2, 3, 4 bond. This guy has 1, 2, 3, 4 bonds. This guy has 1, 2, 3, 4 bond. This guy has 1, 2, 3, 4 bonds. That means my structure is correct. Let's take some more examples. We have to write the condensed and bond line formula for this. So let's first write the structural formula, because from structural formula we can easily write bond line formula. So this guy has 1, 2, 3, 4, 5, 6, 7, 8 carbons. Correct. So first carbon is, let me draw 8 carbon first. 1, 2, 3, 4, 5, 6, 7, 8. Right. The first carbon has 1 OH. Just add OH here. And 2 hydrogen added. Second guy has 2 hydrogen. Pretty easy to add. Third has 2 hydrogen. Pretty easy to add. Fourth has 1 hydrogen and 1 methyl group. So you have to add 1 hydrogen and 1 methyl group here. That means this carbon which I took was wrong. It is a normal bond, because this is 1 hydrogen and 1 methyl group here. This is also done. Sixth also has 1 hydrogen and 1 methyl group here. And then I have 8 carbon which has 3 hydrogen. So 1, 2, 3, first, second, third, fourth. Let me check. 1, renumber it. 1, 2, 3. This guy is 4. This guy is 5. This guy is 6, 7, 8. That is how it is. Yeah. Correct. All the carbons are numbered now properly. This is my structural formula. Let me check if I have done correctly. Let me check if all the carbons has 4 bond. 1, 2, 3, 4 bond here. This carbon has 1, 2, 3, 4 bond. This carbon has 1, 2, 3, 4 bond. This carbon has 1, 2, 3, 4 bond. This is straight now here. This is 1, 2, 3, 4 bond. This carbon has 1, 4 bond. This carbon has 4 bond. All the carbon has 4 bond now. Now let me draw the bond line formula for this. So to draw a bond line formula, I have to remove all hydrogens. I can't remove OH, but I can remove hydrogens. All the hydrogen has to be removed. And all the carbon is a dot now. So how many dot I have? 1, 2, 3, 4, 5, 6 dot in a line, right? So let me draw 6 dot. 1, 2, 3, 4, 5, 6. These are my 6 dots now. Correct? Each dot represents a carbon. 1, 2, 3, 4, 5, 6. Correct? This is my carbon number 1. This is my carbon number 2. This is my carbon number 3. This is my carbon number 4. This is my carbon number 6. And this is my carbon number 8. Correct? Now the first carbon has OH group attached. So let me add OH here. Done. Now this is done, 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 this is done. So I am remain with this guy. Fourth carbon has CH3. So fourth carbon has CH3 attached. Done. And now sixth carbon has 1 CH3 attached. So attached like this. Done. So this is my structure. This is my bond line formula. Hope you understand this. See, you first draw the structural formula, remove all the hydrogens, and then draw the structure in this fashion. And that's you get the bond line formula. Let's take one more example. We have to expand the bond line formula to show all the atoms including carbon and hydrogen. Correct? Let's take the first example, this guy. So we have 1, 2, 3, 4, 5, 6. Let's draw first these 6 carbon. 1, 2, 3, 4, 5 and 6. This carbon and then this carbon drawn here, and then 2 carbons in the tail. This is what it looks like. Now let me add hydrogen just to make sure that all the carbons has 4 bonds. This carbon has 2 bonds, so let me add 2 hydrogen here. This carbon also has 2 bonds, so I need 2 more bonds to make it 4 bonds. This carbon also has 2 bonds, I need 2 more bonds to make it 4 bonds. 2 bonds, I need 2 more bonds to make it 4 bonds. 3 bonds, only 1 bond required to make it 4 bonds. 2 bonds, again 2 more bonds required to make it 4 bonds. This carbon also has 3 bonds, only 1 bond required. This guy has only 1 bond, so 3 bonds are required here, so 3 hydrogen. This guy also has 1 bond, so we have 3 more bonds requirement to make it stable. And thus this is my structure. This is done. Let me take another one. Let me draw this guy with red. So we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. Let me draw 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 is done. Now just have to make sure I add sufficient hydrogen to make sure all the carbon has 4 bonds. This carbon has only 1 bond now, so let me add 3 hydrogen. This carbon has 2 bonds. Let me add 2 hydrogen to make it 4. 2 bonds, 2 more hydrogens to make it 4. 2 bond, 2 more bond to make it 4 bonds. 2 bonds, 2 more bond to make it 4 bonds. 2 bonds, 2 more bonds to make it 4 bond. 2 bonds, 2 more bonds to make it 4 bond. Only 1 bond, so that 3 more bond to make it 4. Correct. Let's take the third one, the blue. So this guy has 1, 2, 3, 4, 5 carbon in a straight chain. So 1, 2, 3, 4, 5. The first carbon has, the first 2 carbon is attached with a triple bond. So let me add triple bond. First, second, third, fourth. The fourth carbon has OH group. So let me add OH group. Now what I am left with is just add hydrogens to make sure all the carbon has 4 bonds. This carbon has 3 bonds, add 1 more hydrogen, make it 4 bonds. This carbon has 1, 2, 3, 4 bonds, so no carbon is required, no hydrogen is required. This carbon has 2 bonds, so let me add 2 more hydrogen. This carbon has 1, 2, 3 bonds, so let me add 1 more hydrogen here. So this carbon has only 1 bond, so I have to add 3 hydrogens here. 3 bonds. This is how my structure looks like. Let's take the last one with this color. So if you see this 1, 2, 3, 4, 5, 6 carbons, let me draw first these 2 carbons in the center. So there are 2 carbons here, and then each carbon is linked to 2 more carbons. 1 carbon here, 1 carbon here, 1 carbon here, 1 carbon. That's all the structure. Now just we have to add ample number of hydrogen to make sure that all the carbon has 4 bonds. This carbon has only 1 bond, so let me add 3 hydrogen. This carbon has also 1 bond, so let me add 3 hydrogen. This carbon has 2 bonds, 3 bonds actually, so only 1 hydrogen is required. This carbon also has 3 bonds, only 1 hydrogen is required. This carbon has only 1 bond, so 3 hydrogen, 3 bonds are required. This carbon has only 1 bond, so 3 more bonds are required to make sure they are 4 bonds. And that is my structure. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.